Alright, hello everybody. I am going to do question 3 of this one-dimensional kinematics. So this one reads, a car is traveling at 56 kilometers per hour. The driver slams on the brakes when they are 24 meters away from the barrier. Unfortunately, the car hits the barrier 2 seconds later. So the questions are A. What is the magnitude of the car's constant acceleration before impact? And B. How fast is the car traveling at impact? Is I'm going to make our axes the usual XY axis where going to the right is positive and going up is positive, but Y won't play a role in this problem. So let's just draw the car. So we got a car and it is traveling. Let me just draw the tires there. It is traveling at 50, so we can just say VI is 56.0 kilometers per hour. Now these are not metric units, so we're going to want to convert those kilometers to meters and the hour to seconds. He then slams on the brakes. So let's say he slams on the brakes at this point, at this moment. Now this means the acceleration begins to go negative. It decreases the acceleration or increases it in the negative direction. So now the goal, of course, is to stop the car. But what ends up happening is he ends up still hitting the barrier. Just draw it like that. This distance here is 24 meters. And it took 2 seconds. And we can call this distance, we can say this is xi for initial and xf for final. So this is where the barrier is. Of course, we can always just set xi to 0 and make xf 24. Like I said in the other video, distances are always just the difference between 2 points, the straight line distance between 2 points. Now, well, displacement, technically. So that's fine. Now let's see what we can do. We're going to calculate for the acceleration. So to solve for the acceleration, we're going to have to use the quadratic formula of the equations of motion. So that one says that the distance, xf minus xi, is equal to the initial velocity, vi, times the time, plus a half acceleration time squared. So we know that this is 24 meters, and we know the times are 2 seconds, and we know the initial velocity is 56 kilometers per hour, but we don't want to work with kilometers per hour, so let us convert kilometers per hour into meters per second. So VI is equal to 56.0 kilometers per hour. Kilometers per hour can be written as 1 kilometer over 1 hour. And then we can continue and say 56.0, and then 1 kilometer is 1,000 meters, and 1 hour is 3,600 seconds. Now we can just plug this into the calculator, and we end up with an answer of 2 decimal places. We can make it 15.56 meters per second. So now at least we're working in the metric system. And now the problem just becomes an algebraic one where we just make A the subject of the formula. So let's do that. So we can start by putting it on the left hand side. So half at squared is equal to, and then put everything else on the other side. So it's still xf minus xi minus vit. So this goes on the other side like that. But we're not ready yet. We need to get rid of the half and the t squared. So we've got t squared over 2. So to get rid of that, we must multiply by 2 and divide by t squared. So a is multiply by 2. Okay, this is just what was on the right hand side, and divide everything by t squared. And we should be able to plug this in, so we've got 2 times xf is 24 meters minus 0 meters minus the initial velocity was calculated over there, that's 15.56 meters per second, and multiplied by the time, which is 2 seconds. And all this is in brackets, just excuse all those brackets there. And then we're dividing everything by 2 seconds. Oh, that was terribly skewed. 2 seconds squared. Okay, let's go over here. So this number here, I mean, you can put it in a calculator, but you can probably do it in your head as well. So 15.56 times 2 should give us something like 31.12, I think. So we end up with 2 times 24 meters minus 31.12 meters. Why is it meters? Because the seconds to the minus 1 cancels with the seconds. And all of this is over 4 seconds squared, because 2 seconds squared is 4 seconds squared. And I mean, I'm really doing this in many steps here. I mean, we could have just jumped straight to the answer here. 24 minus 31.12. I mean, it's negative 7.12. Or meters over 4 seconds squared. And now I'm just gonna put this in the calculator here, and this is equal to negative 3.56 meters per second to the minus 2 meters per second. And this is the acceleration. It makes sense, even intuitively. It is negative because he slammed the brakes, and it's a reasonable answer. So if we do question B asks, let's just remind ourselves what B asks for. How fast is the car traveling at impact? So for this one here, we need the final velocity. So what was the velocity as the car traveled when it finally reached over here and it collided with the barrier? What was its velocity there? Well, we've got the acceleration, so we could use the acceleration in this question. So suppose we could do something like Vf is equal to Vi plus At. So Vi was 15.56 meters per second plus, and the acceleration is negative 3.56 meters per second, and the time is 2 seconds. Okay, yeah, I think let's also just use the rather calculator, because okay, well, let's see, 15.56 meters per second minus 7.12, and then the second to the minus 2 times the second, it becomes second to the minus 1, so our units are consistent, and this is equal to 8.44 meters per second. And that makes sense, and that is correct, and that is reasonable. So unfortunately, this poor driver still crashed at 8.4 meters per second. Alright, thanks guys, we can do the next question in another video. Okay, thanks, bye bye.